Okay. Hello, everyone. Welcome to the graduate seminar series here today on November 12th. My name is Brendan, and I am a member of the Agronomy Graduate Student Organization. We're excited to see you here again this Friday. And today we have Lian, who is going to give a talk to us about some work done at Zamorano University in Honduras, working on cover crops and tillage practices in a maize system and some of the benefits that may offer. So as a reminder, out of respect for our speaker, please remember to mute yourself during the presentation. And if you have any questions, you can write them in the chat or save them until the end and unmute yourself to ask at the end. So thank you, and I will give Lian the floor.
So thank you, Brendan, for the introduction, and thank you all for being here today. I will be talking about my bachelor thesis, and the topic was effect of Crotalaria juncea as a cover crop and no-tillage system on weed control, soil improvement, and maize crop development. So I want to let you know my interest in this research with a little background. Agriculture has a fundamental role in economic development of countries, even more so in less developed countries. So in some of the world's poorest countries, agriculture accounts for more than 30% of economic activity. And in the less developed countries, as a group, it accounts for 27% of gross domestic product. So intensification without environmental criteria has resulted in soil degradation and increased risk of contamination. And the search for short-term productivity over ecological sustainability practice in recent decades has left a worldwide toll of pollution and poisoning. So what can I do for change this situation? The alternative to this problem most necessarily is development of cultural alternatives, and cover crops and tillage system has an important role in agriculture system because both are intended to introduce the concept of regenerative agriculture. For that, and because in my country there not exist a lot of studies about this, the objectives for this research were three. One, evaluate the effects of different tillage systems in association with cover crop on the incidence of weeds in the crop. Two, determine the effects of tillage system and cover crop on the improvement of soil physical and chemical properties, as well as on corn growth and development. And the last, Zamorano. Methodology. The study was conducted in Honduras, specifically a lot in Zamorano University. It was 800 meters above sea level. Total precipitation during the experiment, 600 millimeters, and a mean temperature of 23 degrees Celsius from September 11, 2020 to June 10, 2021. So the experiment had two phases. The phase one, cover crop establishment and development, which was planted on September 11, 2020 at a density of 250,000 plants per hectare. At flowering, the Crotalaria was cut manually or incorporated with a harrow pass, and this crop was not fertilized. The second stage, planting of corn variety Tuxpeño to evaluate the performance in the different treatments. So this was planted on April 9, 2021 under a drip irrigation system to supply missing moisture, and the density was 62,500 plants per hectare. Description of treatments. The leguminous species Crotalaria juncea was evaluated as a cover crop into tillage system during a single cycle. For that, the treatments were no tillage with cover, no tillage, no cover, conventional tillage with cover, and conventional tillage, no cover. Experiment design, it was a split plots with a 2x2 factorial arrangement, and I divide the lot in two, one of the half for no tillage and the other half for conventional tillage with 3 replications each one. I made an endeavor using a statistical analysis system, SAS, separation of means, else means, and with 95% of confidence. So in order to know the physical and chemical condition of the soil, 30 days after sampling, 12 pits were made and where data collect and take samples every 10 centimeters deep up to 30 centimeters. Chemical analysis for the soil, it was determined organic matter, pH, macronutrients, phosphorus, potassium, calcium, magnesium, sodium, and the total of nitrogen. Physical properties determine rooting depth, penetration resistance, aggregate stability, and bulk density. For chemical analysis for the plant, it was determining nitrogen, potassium, calcium, magnesium, and phosphorus. Field variables in the crop, plant population, with count, plant height, number of leaves, and biomass performance. So results and discussion. I divide these results in 3 for soil variables, plant variables, and field variables. In the table 2, you can see the effect on soil variables, and in the interaction, tillage per cover, significant difference were found in organic matter, varied among the treatments at the depths to 10 to 20 and 20 to 30 centimeters, and conventional tillage with cover, no tillage without cover, present the lowest significant values. Likewise, in the 0 to 10 centimeters fragment, the structural stability and penetration resistance, the tillage factor alone had a significant positive effect, being lower in conventional tillage. In the intermediate fragment, 10 to 20 centimeters, tillage had a positive effect, decreasing penetration resistance and bulk density. And for the last fragment, evaluate, tillage had no significant effect, and the use of cover had no effect on any variable at different depths. In the table 3, you can see the matrix of nutrients. I want to highlight that conventional no tillage with cover favor the phosphorus uptake by the plant. In table 4, effects on plant population and root depth. No significant difference were found for the variable plant population. As for root depth, significant difference were found between the treatments, and a clear effect of tillage and the use of cover was found, and since both favor root growth. In the table 5, effects on wheat population 15 and 45 days after planting. In the first sample, significant difference were found for Sclerocarpus phylloscephalus and Echinocloa colona. Conventional tillage was more efficient in the suppression of Sclerocarpus, and no tillage with cover was more efficient in suppressing Echinocloa. In the second sample, significant difference were found only for Sclerocarpus phylloscephalus, and again, conventional tillage with cover was more efficient. Table 6, difference in corn crop height. Significant difference were found in all the samplings, no matter the date after planting. But since we compare these two factors for separately, significant difference were found and showing better results, conventional tillage and the use of cover crops. Effect on leaf number and biomass. No significant difference were found for the variable number of leaves. However, when comparing the use of cover versus no cover crop treatments, significant difference were found, obtaining a higher number of leaves in the cover crop treatments. Significant difference were also not observed in crop yield as a function of the 4 treatments, but a tendency of higher values is identified in both tillage, where significant difference evidently found and with a higher mean for the treatments with cover crops versus those without cover crops. So for answer the objectives that I mentioned at the beginning, I want to remember the first, the effect on the incident of the weeds in the crop. I can say that in the first year under no tillage with cover, there was not a clear effect on the composition of the weed community in the most dominant weeds. Conventional tillage with cover was more efficient in suppressing Sclerocarpus phylloscephalus at 15 and 45 days after planting. The second one, the effect on physical and chemical properties and corn growth and development. Incorporating Crotalaria juncea as a cover crop for the production of a corn crop cycle, conventional tillage present the best results in height, root length, and improved soil properties, such as bulb density and penetration resistance, despite the decrease in organic matter content. And for the last one, with the first no-tillage cycle, no favorable results were observed for corn production in its different variables, nor in soil quality compared to conventional tillage with or without cover crop. And what is next? All future steps for my research. Establish the cover crop as close as possible to the planting of the corn crop so that it can act as a mulching and be more efficient in suppressing weeds. Compare the effect of the association of several cover crops versus the use of a single species, as in this research. Evaluate the biodiversity of agrosystem through the population of possible pests and biological controls, as well as the soil biota in each of the treatments. And for a farm with the objective of increased income in the short term, the use of conventional tillage with cover crops is recommended because of the direct impact on the yield of the corn crop. And finally, follow up for several years to establish a timeline and obtain a better view of the effect of the soil management on weed suppression, soil evolution, and crop development. And an important thing, conduct a study to analyze the profitability of the application of no-tillage system with the use of cover crops. So my reference and acknowledgements for my advisors, the Master Ronnie Muñoz and the PhD Gloria Arevalo de Gaugel, and to my Zamorano colleagues that helped me to this makes possible. So thank you, and I would like to any questions.
Thank you for the presentation. It was great. I have a few questions. This comes from Anna, and she's wondering how you estimated weed population throughout the summer and sort of the methods that you used.
Sorry, I could listen the question. Can you repeat?
Yeah, of course. Anna was wondering how you calculated the weed population throughout the summer. Or
Okay.
yeah.
I- okay. For the frame, and I made a content for the widths, and then I identified 45 widths in the crop. But these 45 widths, I choose 6 like dominants, and then with statistical analysis, I can give the results for the significant difference in the widths.
We have a follow-up to that question is when, how did you determine when you were going to measure the weeds?
Okay. I choose these dates because that is when 15 and 45 days is when the wheat population is highest, and the farmers use pesticides and other controls.
Sure. Anyone else have any questions? I have one other question. I was wondering, for the no-till plots, is there a history of no-till, or was it just for that growing season?
For the what?
The plots that received a treatment of no-tillage,
Okay.
was there previously no-tillage, or was it just for this growing season?
Just for this season, but before start this experiment, it was a lot with only weeds.
I would like to say something. Can you hear me, Brendan?
I can.
Yeah, thank you. So thank you so much, Lian. I just want to share that Lian is an undergrad student at Zamorano. So she's sharing her thesis here with us. And I really appreciate that she was willing to share, even though her English is not her first language. And I know this was, she took a long time to practice and prepare her presentation. So thank you so much, Liam, for your efforts and for sharing your results with us. I know that you choose that topic because this is the first time that this type of research is conducted at Zamorano. So I think that will help. This is like the foundation. So your results will be important for the future studies at Zamorano. And thank you so much, Liam.
Thank you too, Annie.
Yeah. Are there any other questions before we end the meeting today? Okay. Well, thank you very much, Leon. It was a very good presentation. And we hope to see everyone here next week. I believe we have another presentation. Holly will send out an invitation with some information. So thanks for coming, everyone.
Thank you.
Thank you.